Okay, so this is Group 8's meeting on Tuesday, the 21st. And we are going to go over the homework quiz. So the first question, I'm downloading the bone mineral density information. And the first question is, what is the null and alternative hypothesis? I put the null as all means are equal, alternative as at least one of the means differ.
Hey, can you guys hear me?
Yeah.
Check the requirements for this data are met. Check the data are normally distributed in each group, that the variances are equal for each group. Which of the following statements is true?
Hold on. Are we in the lesson 14 meeting quiz?
Yes.
Okay. I'm missing something then.
Yeah, mine's different.
Yeah,
Yeah.
The first question, well, question 3 is, in an ANOVA hypothesis test, we reject the null when there is sufficient evidence. But I don't think that's what you have, is it, Marie?
No, so I'm on 14.
Yeah, that's what I've got is the one that...
You know what? I opened the wrong one. This is bad news.
I was a little...
That's okay. You were just super excited about lesson 15. That's all.
I'm sorry. So this is bad news. Let me just open up a new tab and then I'll do the homework quiz a little bit later. That's what happened. I'm sorry, guys.
No worries.
No, you're good. Okay, so in an ANOVA hypothesis test, we reject the null when there's sufficient evidence to indicate at least one mean is different from the others. I'm pretty sure it's true because the alternative mean is defined as at least one of the means differ.
Yeah.
So I would think we would reject the null if the alternative proved true. Question 4, what requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply. I don't remember this one. So I'm going to look through real quick.
There are 2 requirements of an ANOVA. The data are normally distributed in each group, and the variances are equal for each group.
Okay, that's what I was thinking, but I didn't want to say it and be wrong.
To check if each group is normally distributed, do the following. I think isn't it a histogram?
I believe so, yes.
That's what I thought.
Looking through. Oh, wait. What was the question one more time? If the data is normally distributed. We check this by creating a QQ plot.
It's a QQ, yeah.
Yep.
Histogram's not, it's the bars.
Yep.
We assume the
I'm
variance.
liking these multiple choice.
We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variance. The largest sample mean is less than 2 times the smallest sample mean. Oh, this one was...
If the largest variance is less than or equal to 4 times the smallest, we conclude the variances are equal.
Yep, that's why. So the largest variance is less than 4 times the smallest variance.
Oh, and there go the multiple choice.
And An ANOVA hypothesis test is equivalent to conducting independent two-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples?
There would be 1, 2, 1,
There'd be
3,
6.
2. Yeah.
I'm sorry. Yeah, 6.
Oh, you're good. Yeah, I think it's 6.
6.
Because you just factor it, right? If it's 3, it's 2 plus 1. And if it's 4, it's 3 plus 2 plus 1.
Yep.
Well, okay, hold on. So 3 samples, there are 3 pairs, 1 to 2, 1 to 3, and 2 to 3.
Mm-hmm.
Yeah.
So what would the 4 be?
4
1
would
to
be 1 to 2.
4 would be 1 to 2, 1 to 3, 1 to 4, 2 to 3, 2 to 4, and 3 to 4.
Okay.
Oh, okay.
Yeah, because it doesn't matter which order the pair is in.
Right.
So it's just the number of combinations.
Okay.
Okay, so the data in Soccer Shoes XLSX was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, and D, A, B, C, D, and E, and also just wearing socks for a total of 6 groups. That would hurt. Each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target. So smaller numbers are more accurate.
I hate being the one that like detracts from the focus of the group. I had a prank on Facebook where they paint a soccer ball as a bowling ball as a soccer ball, and people go up and kick it.
Oh my
Yeah.
God.
That's so dangerous.
That is,
Yeah.
You could like easily break your ankle doing that.
yeah.
Yeah.
you could.
Well, and if somebody doesn't have enough strength in their legs, they trip over the bowling ball trying to kick it.
Yeah, you-
And the smallest and the largest variance for the 6 groups.
Let's see.
Well, that's not fun.
Let's see. Downloads.
Okay, so I got the smallest variance as variable 1, and I got 27.358.
I'm almost done filling out the ANOVA thing. I wasn't sure what to do at first, but I think I got it.
Four times.
So you said variable 3 had the smallest variance, 27.208.
Yeah, well, yeah, that's the right one. I took variance 1, but I didn't look at 3. So 3 is the smallest, 27.208. And then the largest I got as variable 4, 53.158.
Yes, yep, that's what I got, 53.158.
Okay. I'm just finishing up, and then I can.
How did you guys find that?
So on that, like, ridiculously OP X, you have like the 1 sample t-test, the 2 sample t-tests. There's one tab labeled ANOVA, which means analysis, and you just fill out each variable in the table, and it gives you all the numbers.
Oh, gotcha.
Go A, copy in variable 1, B, copy in variable 2, and then you have all the answers. Okay. So the test is satisfied. This would be satisfied because it's less than 4 times as much, right?
Yeah.
Yeah, that's true. How do I construct a QQ plot in here?
I think there's another Excel sheet called the quantitative descriptive statistics or something like that.
Oh, okay.
It was in the lesson. I'm pretty sure that, yeah, I just opened it up. There's a tab
Yeah,
for
quick statistics. Going to close, so I'm just going to always have all of them open. Do I sound like really choppy to you guys?
Yeah.
My internet is really, really slow.
Are you in Rexburg?
Yes.
Okay. Yeah, that's probably why. There's like a whole bunch of wind advisories and stuff going on right now. So it's
Same with Utah.
nice.
It is very windy.
Okay.
QQ plots, do we have to copy in every single variable?
I just copied all of them and dropped them in because there's only one column.
Yeah.
Right.
So I just,
But don't you remove the sock data? Maybe not.
I don't know.
That might be a later question.
smallest to largest.
So
I would think that's normal. I mean, it's pretty much on the line and it's all in the same areas. Here, I'll go
You have
ahead
to
and
do each
share.
one by one.
Do you?
Like I tried copying every column at once and it doesn't work.
Wait, what?
okay, and then we need to sort.
Here, let me share my screen and I'll show you what I did. So I just pasted all of the values from soccer shoes into this column and then sorted from smallest to largest. And this is what it came up with.
That looks pretty normal.
Yeah. So I'm thinking it is normalized. And I mean, it even shows us like the standard deviation here and everything. So I'm thinking it is normalized.
Yeah, I would say yeah. That's what I got too.
Okay. SPSS, serve the p-value is 0.081.
I don't know how to do this one.
Okay, so we just delete variable 6.
Oh, in our other spreadsheet.
I got 0.309.
Sorry, you kind of broke up for me. Was that 0.309?
Yes.
Yeah, that's what I got as well. Test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left of the F statistic?
The p-value for the area in the right tail.
Right, yep.
Mm-hmm.
Researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat, mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data available
Construct QQ plots of the calories. For just the 3 types.
Let's examine the calories first. Construct QQ plots.
Oh, that is to sort it too, huh?
Yep.
Just sort it.
Is there an easy way to do that? Sort. Oh, okay. Smallest to largest. That looks, yeah, that looks way different. If it's not sorted, it looks like a disaster.
Yeah,
Yeah, I
that's
made
a
that mistake
disaster.
too the first time, and I was like, "That."
I'd say that looks pretty normal. Kinda.
Hold on. Custom sort. That smallest to largest. Okay. Yeah, I would say it looks pretty normal.
Yeah.
Well, but don't we need to? It's like the answers. It's safe to assume each group comes from a normally distributed population, but we cannot assume the variance
Or
because
equal.
we don't know what the variances are yet.
Yeah. I would agree. 15, run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51, that F equals 16.074, and that P equals 0.000 with a level of significance equal to 0.05. What
Do we
conclusion?
actually need to run that test?
I don't think so. I'm trying to think. The F value is the one that I don't remember which
What's our test?
which one is supposed to be less than 4 times.
Your
is it-
P. That's your that's your variance.
Variances.
Okay.
But your P value has your P value, if it's less than your level of significance,
Uh-huh.
then we reject the null hypothesis.
Okay.
If the p-value is greater than the level of significance, we fail to reject.
But
Yeah.
what is it? Where does the F
That's what I'm
come
trying
into
to
that?
figure out.
Well, the F statistic. I thought the F statistic was the same as the T, but since this is not, no, it's right skewed usually.
Okay.
Because it's like the T
Um,
score.
So in step 4, it says QQ plots indicate that it is reasonable to conclude that the data are normally distributed in each group. That's for the example. The largest variance, 0.8917 from the Grateful group, is not 4 times the smallest, 0.6922 from the Hassels group, so we conclude that the variances are equal for the 3 groups. And then it's got a thing saying, give the test statistic and its value. This can be found in the output. Our test statistic F is 4.075.
Yeah.
So I think that is, what am I trying to say? I don't think that has anything to do with whether we reject the null hypothesis or not,
Okay.
because just below it only talks about the p-value.
Because that's going to determine your p-value.
Yeah.
Because your
So
S.
they're related, but that doesn't really have any effect on the conclusion here. The important one's the p-value.
So what can we conclude?
We should be able to reject the null hypothesis here. And so that should mean that we have about the same. So I would say it's the first one. We have sufficient evidence to claim that all 3 hot dog types have the same mean number of calories, because the null hypothesis is that none of them vary, like past that certain point. The alternative hypothesis for these guys is always that at least one of them varies. So they should have
Okay.
the same mean number of calories.
So it should be the bottom one that at least one has a different mean.
Yeah.
Do I have it backwards? Because I thought if the p-value was lower than the level of significance, then we can reject the null hypothesis. Is that backwards?
Yeah.
The,
No, that's right.
Okay. And the null hypothesis is, oh,
all
yeah,
the-
yeah, you're
all
right.
the means are
We
equal.
reject it. Yep.
Where is the null hypothesis? I don't see that.
It was in the reading. It said that for, let me,
But I mean, for this particular, for the hot dog thing, like
it's,
they don't actually declare a null hypothesis.
no, but for the ANOVA tests,
You're saying by default, it's just
yes.
that there's one that's different. Okay.
Yep.
Okay, so you guys put, we have sufficient evidence to claim that at least one of the hot dog types has different mean number of calories than another type.
Okay, I see. The null hypothesis is always that all the means are equal.
Yes.
Yeah.
Okay.
Now let's examine the sodium levels. Construct QQ
Same
plots
thing
of
for
sodium
sodium.
levels.
Okay. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variable variance is 7180.75, and the largest is 1049, 10,492.87. Have the assumptions been met to use ANOVA? That's a good question.
Yes, they have been met because
Yes.
the QQ plot is very normal.
Is
Mhm.
normal. Is the largest 4 times. So the assumptions have been that it's okay to assume each group comes from a normally distributed population, and we can also assume that the variances are equal.
Yeah, that's the one I'm going with.
Despite the possible problem with QQ plot, you decide to use ANOVA to determine if the mean sodium levels are the C value. Is there a shortcut to paste values? VV. I guess, I don't know.
I'm not sure. Okay, so let me look up how to calculate the p-value real quick.
Are you just pasting it into the spreadsheet?
That's what I'm doing.
I got 0.179.
I got 0.179 as well.
Okay, what conclusion can you draw about the mean sodium levels of the three types of hot dogs? Use a level of significance of A equals 0.05.
So we failed to reject the null hypothesis.
So we do not have sufficient evidence.
To reject the claim.
Yes.
Yep. Okay. Let's see what we got. Two, good, good, good. We only missed one of them.
Which one?
Question 14.
Construct QQ plots and compare the variances. The assumptions have not been met. This is the one we didn't know what the variances were.
Yeah.
The assumptions have not been met. While it's safe to assume each group comes from a normally distributed population, we cannot assume the variances are equal. Assumptions have not.
Yeah, I'm thinking it's that one.
The second one.
Oh.
Yeah, because we saw that it was normalized, but that doesn't mean that the variances are equal.
Okay, I can submit and see.
Wait, isn't the second one the one we already tried?
No,
No,
I tried the last one.
Fourth one was the one we tried.
Oh, I had the second one highlighted.
Do you want to submit, Mitch, or do you want me to?
I'll do the second one.
What was number 15?
Number 15 was we have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type.
Okay.
For 14, the second one is wrong.
Well, geez.
I think it's the first one.
Might as well try it. We have enough attempts. If it's not that one, when we know it's...
I'm going to submit, I'll tell you. First one.
Jeez.
So
Like
it
a
is the
boss.
first one.
Assumptions has been met. It's safe to assume that it comes normally distributed, and we can also assume the variances are equal.
But how do we know the variant? I guess it says compare the variances. So like, I guess we're supposed to figure them out.
Yeah, I think we could have pasted it
I
in.
I got 16 wrong. What was 16?
16 is
The assumptions have been met. It's okay to assume each group comes from a normally
the
distributed.
very top one.
Oh, okay.
The assumptions have been met. Yeah, sorry.
Okay, great job, guys.
I'm liking these fill out the spreadsheet and win.
I know, right?
Yeah, those. You know what, Mitch? Did you figure out how to calculate the margin of error for other?
Or at least I did on the homework quiz because I got them right on the homework quiz. I don't know. I didn't really go back and try to figure out for the group meeting quiz that we didn't do.
Okay. If I send
I think
you,
he said in that email that we
Wasn't it like we put them in
were
backwards or something like
subtracting
that?
the wrong data. Yeah, like we had group 1 as group 2, and that way when we subtracted them, it was all negative number, all negative from what they were supposed to be,
yeah. Okay.
which makes sense. I guess we didn't read it carefully enough.
Okay.
Where did you guys find that new Excel sheet for this week?
There's a link for it in the reading.
Oh, okay.
In the reading. And then that page that I sent you guys a week ago.
Yeah, the link Marie sent actually has the link to all. That's just what I used.
Yeah.
I would bookmark that page or save it to favorites or something.
Yeah, I bookmarked it because you're going to use it a lot. So I emailed Anders about the margin of error, but Mitch, can I send you an email and ask you how to calculate it? Because I'm not understanding that like I should.
Yeah, sure.
Okay.
Pretty much all you do is you find the upper and lower bounds and you add them together, and but you need to have the correct upper and lower bounds. So like if you had 40 and 60,
Yeah.
you would add them together to get 100 and divide by 2. And the mean would be 50. And then you just figure out what the margin of error is by subtracting that from the upper bound. So 60 minus 50 would be 10. So the margin of error would be 10.
Okay.
If that
So
makes sense. So there's like multiple steps.
okay. So you take the upper and lower bounds, you add them together, divide by 2, and then you take the mean.
Then you take the mean and you subtract it from the upper bound.
Yeah. So the number that you get is the mean. And then you've just got
Yes.
to figure out what the difference is between the
Yes.
mean and like the upper bound.
And then if you want to double check that you're correct, take the lower bound. You should get the mean, add the margin of error again. You should get the upper bound, then it's not correct.
Add margin of error. Get mean. Add again. Upper bound. Okay, I'm gonna try this.
And it's a little tricky for negative numbers. I'm trying to think of a good way to explain it. So if you had like negative and 30, then if you added them together, you would get 20 as your mean, and you should, or you'd get 10 as your mean.
Okay, yeah.
I guess if it's a negative number, add the absolute values. I don't know. Do you guys? I know how to figure it out. I don't know how to explain it.
Okay. So I think if it's a negative number, you still.
Then you'd add the absolute values together.
Yeah.
Divide by 2. The mean.
Yeah.
Or
So
the
say you had a lower bound of negative 10 and then an upper bound of.
it would still be right.
Yeah.
Because you would get 20 and then divide by 2, and you'd get the mean as 10, which is correct.
Yeah.
Minus 30 would be 20, which is the margin of error, which would be correct.
Okay, so your margin of error would be, so you would do 30 minus 10, and it would be 20. Is
Yes,
that your margin
because
of
you
error?
got a mean of 20. Sorry, you got a mean of 10. Would be 20.
Okay, so this is your margin of error. Okay.
Green. Oh, okay. I see. Never mind. Sorry, I'm like, there's a little bit of a delay and it's like choppy.
That's okay. Thank you.
Yeah. Well, thanks, guys. I'll see you on Thursday.
Bye.
Yep. Have a good night.
Hopefully my connection's better by then.
Yeah. It's all good.